today's lesson, we're going to be talking about factoring. So what exactly does factoring mean? Well, when we factor, we're going to factor a quadratic equation. So factoring means we're going to unmultiply or do the reverse of the distributive property that we talked about in the last section to solve a quadratic equation. So what exactly is a quadratic equation? A quadratic equation is an equation where the highest power of the variable x is going to be 2. So let's look at some examples of what is a quadratic equation. An example of a quadratic equation might be something like x squared plus 5x minus 6, or x squared minus 4, or maybe x squared by itself. Those are all quadratic type problems where the highest variable of my x is 2. Some non-examples of quadratic equations would be something like x plus 2. We know that it's a non-example because that one is linear. X cubed minus 9, because my x has an exponent of 3, that's cubic. So that is a non-example. Maybe x to the 5th plus x to the 4th minus 4x squared is a non-example because even though it has an x squared in it, the highest exponent of my equation is 5. Therefore, it is a non-example. So let's talk about this concept of factoring. First, we're going to factor using the concept of a greatest common factor. So think back to junior high, greatest common factor is GCF. So let's first talk about finding a greatest common factor, or a GCF. So numerically, if I have numbers in a list like 4, 16, and 8, greatest common factor, what is the largest number that evenly goes into those numbers, 4, 16, and 8? Well, I know 2 evenly goes into 4, 2 times, 2 goes into 16, 8 times, and 2 goes into 8 4 times. But is there a largest? Because remember, we want the greatest of the common factors, the largest number that goes into each of these numbers. So if I check, 4 goes into each of them. 4 goes into 4 once, 4 goes into 16 4 times, and 4 goes into 8 2 times. So here, my greatest common factor is 4. Number 2, x to the 5th, x squared, and x cubed. When they are variables, let's think back to what does x to the 5th mean? Well, x to the 5th by definition means 5 factors of x. X times x times x times x. X squared means x times x, and x cubed means x times x times x. So I'm looking for common factors. What do each of these have in common? Well, this one has 2 factors of x, this one has 2 factors of x, and this one has 2 factors of x. And that's what they have in common. They can't have any more in common because this one runs out, my middle term here runs out of x's. So my greatest common factor for this one is x squared. So when I take a look at that, that one is the lowest exponent, or the smallest exponent of x. So if I look at number 3, 100x, 25x cubed, and 75x squared. So let's put the first 2 examples together to find my greatest common factor. So look at the numerical part first, 100, 25, and 75. So if I think about them in terms of money, okay, 100 cents, 25 cents, and 75 cents, I can see they're divisible by quarters. So that's 4 quarters, 1 quarter, and 3 quarters. So I know 25, 1 quarter is my greatest common factor. Then look at the variable parts, 1x, 3 x's, 2 x's, and they each have at least 1x. So my greatest common factor is 25x. So let's start now, do some factoring now that we've established our greatest common factor. So we said factoring is just rewriting an expression as multiplication. We're going to discuss several ways to factor in this part 2 of our chapter. The first method we're going to talk about is the method of this greatest common factor. So we first have to be able to pick out the GCF. So first example, 25x cubed plus 75x squared. My first step is to determine the greatest common factor of the expression. So 25x cubed and 75x squared, find the greatest common factor. So my GCF, 25 and 75, so that has a 25 numerical part, x cubed and x squared. The lower of the two exponents is x squared. Once I've established my greatest common factor, we're now going to divide each term in my original problem by my GCF, 25x squared. And now we're going to write down my greatest common factor, 25x squared, open a parenthesis, and we're going to write it as a multiplication between that greatest common factor and a new expression. The new expression is what do we get when I divide each of these terms. So if I take 25x squared out of 25x cubed, we can see that 25s are going to cancel. X cubed, and I take away x squared, that leaves me with 1x. Put that in the parentheses. Then comes your plus sign. Now your next term, 75 divided by 25 is 3. X squared divided by x squared, they all cancel out. Close the parentheses. How do I check? Well, I check my answer by distributing what we had gotten once I had completed my factoring by a greatest common factor. So use our distributive property that we practiced last lesson, and we should come back to the original problem. So 25x squared times x is 25x cubed. 25x squared times 3 is 75x squared. All right, let's practice. 6x squared plus 9x. So first find your greatest common factor. So 6 and 9, greatest common factor was 3. X squared and x, I can factor out an x. So I'm thinking of dividing each of these by 3x. Put the answer inside the parentheses. 6 divided by 3 is 2. X squared divided by x is x. Plus 9 divided by 3 is 3. Here the x's will cancel. Close the parentheses. Check by redistributing. So when I distribute 3x times 2, that gives me 6. X times x is x squared. And plus 3 times 3 is 9. X times x, or x. So here it checks. So we always have my way of checking and make sure that I come back to my original problem. Number 2, 14y squared plus 7y minus 21. So greatest common factor, look at the numerical part. 14, 7, and 21 all have a greatest common factor of 7. Y squared y has no y's, so there can't be a y in common. So greatest common factor is 7. Open the parentheses. Think about dividing each of these terms by 7. Write your answer in your parentheses. 14 divided by 7 is 2. Y squared plus 7 divided by 7 is 1y. We know we don't write the coefficient of 1 in front of the y. Minus 21 divided by 7 is 3. Number 3, 25b squared minus 20b. So coefficient 25 and 5, greatest common factor there is going to be 5. B squared and b, they each have at least one b in common. So factor it out. So I'm thinking of dividing each of these by 5b. 25 divided by 5 is 5. B squared divided by b is b. 20 divided by 5 is 4. Here the b's will cancel. I'm done. Close my parentheses. Pause the video and try the next 3 on your own. What you got? So did you get a greatest common factor here of 5? When I divided each by 5, I should have had t squared divided by 5. So minus t, and divided by 5 minus 2. So 5 times the quantity t squared minus t minus 2. Number 5, greatest common factor here of x. So when I divide each term by x squared divided by x is x minus 2x divided by x. The x's cancel. So I end up with x times the quantity x minus 2. And number 6, 42n to the 4th minus 64n squared. This one should have been the hardest one because you have the largest numbers to begin with. So 42 and 64, greatest common factor is 2. N to the 4th and n squared, the smallest exponent there is n squared. So when I take 42 divided by 2, that's 21. Take 2 n's away from the 4, that's n squared. Minus 64 divided by 2 is 32. Taking the 2n squareds away, done. So 21n squared minus 32 completed.